Hi. In the last video, I took on a pretty extensive overhaul of Control Logic 1. Today, I'll need to do the same thing for Control Logic 2 and Control Logic 3. While I'm doing that, I'm going to go ahead and build out Control Logic 4 and set aside space for Control Logics 5, 6, and 7. Now, I understand that's a lot of Control Logic modules. At the same time in this video, I'm going to change one of my design tenets and augment how I take care of and latch. Let's get into that.
Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey.
Let's begin today by taking a look at the AND latch signal. On the left here, I have control ROM 3, which the three most significant bits become the AND latch. This is coming off of this ROM here. Now that signal is brought over here inverted twice, and then I've got a 74LS00 here. So that is NANDed with this signal here, with this yellow line, which is the clock. I believe we can simplify that quite dramatically by simply taking the inverted clock there and placing it there. Grab a couple more wires here for jumping, and then extending that same so that all three now pick up the AND latch signal, which is here. All of them are being latched on really the falling edge of the clock, which is exactly what I want it to do. Now, the design tenet I said that I did not want to do is I did not want to extend the clock all the way to each component. I wanted to handle all of the signals natively. And I'm not quite sure I've violated that tenet at this point. While I do have the clock driving the signal, the AND latch is not handled on the board by the data that's given to, or the signals that are given to it, in interpreting a clock as when to latch. I'm actually still in the control logic using the clock to drive the signal. It's a subtle difference, but that same design tenet is it is saved me here, but is gonna extend forward to other portions of the build. So with that said, control ROM 3 can almost go away, with the exception of the fact that there is still the R2 register load increment and decrement. Okay, I'm not going to make much more of a change than this at this point in time. This is working. I will remove the extra lines so that they don't accidentally ground on something and short the build. But I need to get now into control ROM 2 and control ROM 3 and talk a little bit about exactly how those are going to be used and leveraged from here. Let me bring up my plan. I have the code for control ROM 2 up. And if you look closely, you can see that for R1, you've got a do nothing, a load, an increment, and a decrement. And those four functions are handled by 2 bits of that control ROM. I need that functionality for the program counter, at least increment. I need that functionality for the return address register because it could also be a program counter. So again, increment. And for the stack pointer, which will have increment and decrement built in as well. But for the general purpose registers R1, R2 through R12, I don't necessarily need to have the increment and decrement functionality because those bits are not passed through the ALU and therefore flags are not updated. If I'm going to increment R1, it's going to be far more beneficial for me to pass that through the ALU so that I can get the flags updated and execute some conditionals on that. Now, later down the road, I may realize that I need some string operations whereby the automatic increment of a register would be beneficial. And if I need to come back and add that back in for a small subset of registers, I'll do that. R1, on the other hand, if we look at that specifically, the increment and decrement, like I said, don't make a whole lot of sense. So I can have simply a load or do nothing signal. And load is very conveniently the least significant bit of those 2 bits. So I can tie the most significant bit that would travel off to the control signal for R1 to 0 or low, and let the load actually happen just as a single bit from the control ROM. Now, bringing up the plan here, you can see based on all of the different registers and then devices and control spaces that I'm going to have a pretty good list of things that I want to be able to load from the main bus. And it's going to take up quite a few ROMs in order to populate that full list. I get it. I'm ambitious. I did make a discovery as I was getting ready to record this segment that I had neglected the instruction suppress bit. Now the clear carry, set carry, those are going to be handled later when I reintegrate the ALU. But I do need a place to put this instruction suppress bit. And I have a couple of options here. I could either put it right below the memory load or write and push the registers down and eliminate the unused bit in Control ROM 5, which seems like a reasonable thing to do. Or I could put it there in Control ROM 5 and force myself to have to implement that now, which is also a reasonable thing to do. So what I think I'm going to do is I think I'm going to reorganize these because I will end up building out ROM 4, and that'll give me everything I need to hold me solid for a little while so I don't have to go much beyond 4 for the immediate needs. So I will make that adjustment, and then I'm going to get some breadboards out, and we'll start putting the components on breadboard. Okay, so here's where I plan on putting this build. This top 2 boards here are going to be Control ROM 2. That's definitely going to be wide enough. I'm going to need to flow out onto the second board here. Down here, I've got Control ROM 3. Again, it's going to be wide enough that I'm going to have to flow out onto a second board. But Control ROM 4, 5, 6, and 7 should all be able to fit on one. So I'm going to try to put those right next to each other. And then this should earmark everything I need for those control ROMs. Now, off camera between the last video and this video, I did make up a second one of these, and I will be using that in this build. I went ahead and hooked up power and ground all the way down the sides. I hooked up my bulk decoupling. What I need to do is I need to get these joined together so that they are power and ground is bound together. And let me work on getting that done, and this will be quite a bit of fast forward here as I do this. You've seen me do this in the last video. The next thing I want to do is I want to extend my 3 clock signals down the side of the boards here. Now that's going to be in column 1. In column 1 here, that's going to be the clock. Column 2, that's going to be the inverted clock. Column 3, that's going to be my spike clock. And so let me get those wired up here. Again, another fast forward. Okay, well, this is going stellarly at this point. So what I've got here is one of my EEPROMs. I'm just going to use that as a placeholder for now. Next to it, I want to place a latch. And then next to that here for Control ROM 2, I'm going to place I'm going to move that over a little bit. I'm going to place 2 AND gates, or 2 AND ICs. And here's the challenge. Here's where I messed up. I thought I also needed to put 74HC138s here, forgetting that these are actually located on the registers themselves. So I don't need 2 boards side by side. So Control ROM 3 is likely going to end up over here. Let me start with power and ground and decoupling up here. Now each of these 8 data lines coming off the EEPROM need to be brought over here to the inputs into the 74HCT574. Now let me just double check my inputs here. Now I have an output enable on here that I also need to bring low. And then I've got a clock up here in pin 11 that I need to tie back to my clock signal here. Okay, so now I just need to pull my inputs out this way, and then I have to come over the IC. Now you've seen me do this before, so I'm going to zip through this as quick as I can. Okay, next is to extend each of these outputs over to one of the inputs into each of these AND gates. And I will use the leftmost input into the AND gate as my target connection. The next input into the AND gates is the spike clock. The last thing I want to do is I want to collect the outputs here and tie them all into a row, top and bottom here, so that I can connect my ribbon cable in there and pick those up. Well, I apologize. I'm not exactly sure what happened, but OBS stopped recording about 5 minutes ago. So there's a little bit of this that was missed, but I was able to get the second EEPROM that I soldered up between videos in. And this over here, just in case I missed it, gives me a spot to connect my 4 upper and 4 lower signals. So I will be able to take an 8-pin wire, split it in half into 2 4s, and connect it here. And what this allows me to do is it gives me enough room such that when the one that sits here isn't going to interfere here. What I'd like to do is I'd like to open up Visual Studio Code and show you the changes now that I want to make to this, to the EEPROM that's going in here, so that there's an understanding of what all these different signals mean. Well, the Control ROM build has had some pretty significant changes. Related to Control ROM 2, you can see that R1 has been removed from the load increment decrement, and program counter is moved up to its final home as the most significant bits of Control ROM 2. Though I don't yet have the hardware tested for this yet, RA and SP, so return address and stack pointer, are already built into this as well. And the interrupt program counter, moving on to Control ROM 3, interrupt return address, and interrupt stack pointer, all of those have been positioned and are in the correct spots. Now, the only 2 oddball signals here are memory write and the instruction suppress. And I'm not exactly sure what the memory write signal will need to be shaped as yet, but the instruction suppress is active for the entire life cycle of the clock. So both the rising edge, high level, falling edge, low level, all of that is the period during which the instruction suppress will be asserted. Then I start into the specific load instructions for each of the general purpose registers. Now recall that I'm going to remove increment and decrement from these because I want those to be ALU operations and not something that's intrinsic to the actual general purpose register. Now, I did then remove the and latch bits and the increment and decrement bits. And so that triggered a change in all of the bits and how they're being programmed onto the controlled EEPROM. A couple of things I want to call out. First is the removal of these instructions are going to break a lot of the test code that I've written. So I'm going to have to come up with different tests that will exercise a register as I build it so that I can prove to myself that it's actually working properly. And the other call out then is back up here, where really Control ROM 2, most of Control ROM 3, there's a couple of exceptions here that I have to deal with. Also Control ROM 4 and 5 and 6 and 7 all look the same. The hardware is going to be exactly the same. The next step here is going to be to build out Control ROM 3 and Control ROM 4. And what I'm going to do is I'm going to make them look exactly like Control ROM 2. Control ROM 3 is going to have some changes to that, but I'll do that after I have everything built out. Here we go. Since I've already wired something like this up once this video, let me go ahead and jump ahead to the important stuff. So all 3 of these now match, except I've got the ROMs pulled out. But for Control ROM 3, I'm going to add a NAND gate IC, so 74HC00. And the purpose here is I'm going to need to NAND my signal with the clock in order to get the correct signal for the memory write. At least I believe it. That's what I'm going to need at this point. So I'm going to go ahead and put that in there. Now, the reason I can put this here and not anything over here is because I don't have anything that's going to be extending over the top of it. So these are bits 4 and 3 that are going to be needed here. So these are really these 2 hookups. This signal will need to be extended over, and then I need to pick up the clock. which is all the way over here. I'll probably pick it up from this location here, which I'll drag over to its proper spot here and then jump it up. So let me get that little bit done. Okay, I had said 4 and 3, but it's really 3 and 2. So this one is the memory, which is 3, which is going to be the leftmost bit here. Now I will have to pull the other 3 gates on this low. And then this is not needed. This signal is going to go straight over, so I can probably, no, I'm going to have to replace it. And I'm definitely getting some practice on my metallurgical origami tonight. Okay, so the last thing I need to do is now pull this spike clock from here all the way back. Well, I can actually probably pick it up here. The last task here is to make sure that I determine all of these unused signals here. So it doesn't matter if I pull them high or low, I just have to pull them one direction or the other. Just checking my work, and everything looks appropriate. Now to put it in the build and test it. Well, with the build back out, the 8 boards over here on the side that I've been working on need to be put in place of these 2 boards right here. And the good news is power is easy enough to separate out, and I can actually remove these 2 boards relatively easily. I've got a number of jumpers that come down here to where my connection points are, but I should be able to line up, or at least start lining up, my new connections here, saving all of this room for the rest of the main bus assert. Okay, so with that, let me start by pulling a couple of connections here. And I will pull this out to make it easier to work, because I have to pull this line, no longer required. I'm going to separate off these. I'll pull power. I'm going to pull these out for the moment. Okay, those are separated. And those are separated. And again, this is for the ALU. No, it's for the flags. All right, so all of these are the ones that I need to reconnect back. Now, this is getting to be monstrous. Okay, let's pull these out. And now I'm in an interesting position because I only have 2 connections here, which means I should be able to take these 2 out and replace that connection with that, and take this out and replace that connection with that, which removes this small board right here, simplifying this. Now, I will have to pull this down, but I will work on that here shortly. All right, so here are the gamut of signals I need. Control ROM 1 is hooked up. Control ROM 2 is here and here. Let me make sure I have those correct. I do. Control ROM 3, similarly, are here and there. A couple of things I need to do. I need to rehook up clock. Now that connects my clock, inverse clock, and spike clock all the way down here, and my latch signals here are not all tied together yet. So that's one thing I can, whoops, wrong spot. That's one thing I can clean up there. Clear is hooked up. So a program counter, load increment, decrement are the 2 most significant bits on Control ROM 2. R1 is now different because the most significant bit is now tied to ground of that. So I can remove the pull up and just hook it directly at ground. The least significant bit is on bit 1 of control ROM 3. So that's all the way down here. This is my instruction suppress. Instruction suppress should be now off of 3, bit 3. And that, in theory, makes all of the connections that I need in order to restore functionality. I can put control ROM 1 back in, but the reality now is I have to deal with all of these address lines and bring them over into these 3 new ROMs. So I'm going to work on extending that, and they're going to be extended off of this board down this way so that I can extend them into here, extend them into here, and then from here I'm going to extend them over. Let me work on that. Well, this next part is nothing more than a bunch of fussy metallurgical origami, so I will skip through this quickly. I did end up finishing this up. I did not record this portion, so this video is honestly tracking to be a little bit longer than I had anticipated when I started. So I went ahead and finished this up off camera, and then I added an extension here onto my EEPROM. You can see me pulling that away just a little bit. And the reason is because this now sits so high that it does not sit flat. So I have to come up with something to raise this up just a little bit. I do still have some cleanup to do down here, plus I've got some power and ground to deal with here. I've got to get all my power and ground hooked back up so that I can properly power this. And so let me work on getting that addressed, because this isn't going to be long enough anymore, so I'm going to have to find a different way of getting power over there. And then get the cleanup done down here, and then I think I'll be ready to give it a shot, give it a test. While I'm working on the cleanup, I want to call out that I did not wire up the address lines for control ROM 4. Yeah, I'm kicking that can down the road a little bit. It's very fussy to do. I may or may not do that off camera. But the reality is that control 4 will control register 3, register R3. And I don't have one of those yet. Okay, I think I just need to program some... Oh, power. Thanks for reminding me. Okay, now I just need to program some EEPROMs, and I'm ready to apply power. Let me get that done. I have the control ROMs and the program ROMs all programmed. I wanted to take a quick look at the program that I'm going to be testing with. And it's really simple. I've kind of neutered what's available for R1 and R2, so we're really only able to load things either from the instruction stream by way of the fetch register or from other registers. So I'm moving a couple of values around and then I'm jumping back to 0. It's really a basic test just to make sure that I've got all the functionality working properly. So let's power this on and see if it works. All right, let's check and see just how much I broke. I'll put the code up here in the corner. I don't think I'm going to be doing much fussing up here. If anything, it's all going to be down here in this spot, but who knows? Let's power this on. Program counter, R1, R2. Program counter is asserting out onto address bus 1. Fetch register has fetched the first instruction, which is a load into R1. That's progressed up here, so that's good, but I don't believe that's the right value. And my program counter didn't increment. All right. One of the things I was concerned with is, I think I wired this up that this was the most significant bit and this was the least significant bit of the do nothing, load increment, decrement, and all of them are wired up that way. So let me see if I can switch the program counter, and I will reset and try again. And yes, it did. What's going on down here? Oh, that's probably because I have to adjust those. But the program counter appears to be operating properly now. But I'm getting odd increments and what have yous down here. So let's fix that as well. All right, so reset. First should be 0001, which it is, which is good. That'll hop up here. But the second instruction is not happening. My load increment and decrement is not happening properly. But it is, so it's the AND latch that's not happening correctly. So what's going on with AND latch? I pulled out the logic probe and did a bunch of poking around. Nothing really stood out as the problem here. Yeah, I'm gonna have to break out the scope and check those timings out. Well, it's been several hours of probing and looking at the oscilloscope and just generally digging in, trying to figure out where this problem lies. And I've come to the conclusion that it does not exist up here in the control logic that I have been working on, but rather it is in the reset logic. And let me see if I can demonstrate this for you. These are the counter ICs up here in the corner, and if I put my logic probe on the lowest output and reset, it's still 0, so the least significant bit of the program counter is 0. When I push down on the clock, it does not increment. When I release, it does increment, but it doesn't latch until I push down again, and you end up with the program counter finally incrementing all the way to its outputs. I went back to video 65, which is where I declared the reset circuitry clean. And I looked at that in order to determine if I actually had the problem. And I did. Let me show you. Okay, I'm going to go frame by frame here. Here I am in the wrap up of the video. I'm about 28, almost 29 minutes in, 28 minutes, 40 seconds or so. I'm going to go frame by frame here. And what you're going to keep an eye on is my finger on the clock and the least significant bit associated with the program counter. The program counter is up at the top where my left hand is. Frame number 9, frame number 10, frame number 11, frame number 12, frame number 13, frame number 14, and you see the green light turns off, indicating that I'm pressing the switch down. That takes the clock cycle from high to low, and the least significant bit is not lit yet. Frame number 15, I release that, clock cycle goes back high, the least significant bit still hasn't lit yet. Frame number 16, frame number 17, frame number 18, I push the switch again, the green LED goes out, clock cycle's low, and I finally get the end latch. So that's the same behavior I'm seeing today in this build, and so I'm going to have to take a similar approach as I do in my professional life. I have clearly identified and found a bug in this section, but it's totally unrelated to the task at hand and what I'm testing right now. And so if I can work around that bug, then I'll fix it, but it's not going to fail the testing of this circuitry that I've just changed. So I believe I can do that if I change my test scenario at this point. And what I've done is I've added this no op at the beginning. And so what happens is the first instruction at address 0, rather than being a move instruction where the target of that move ends up being a constant value that goes through the fetch register, the extra clock cycle is a no op instruction, which should do absolutely nothing. And if that works the way I hope it does, what that should allow me to do then is test out and prove that this circuitry is working correctly by reprogramming my program ROMs, and then identify, or at least bookmark, that I've got to come back to this reset logic and figure out what's going on with that and resolve that. I'm going to get the new code programmed onto these ROMs, and we'll come back with a second test. Okay, I've reprogrammed the program ROMs, and up in the corner again I will go ahead and stick a copy of the source code, and I've got it up on the other screen for me. So let's go ahead and power this on. So my address is 0 as I expect it to be. My fetched instruction is 0 as I expect it to be. And if I take the clock down and up, my program counter is 0 and my instruction is still 0. So now it's never progressing past 0. And why is that? That should be a no-op instruction. A no-op should increment the program counter. Maybe that's my problem, and I've been barking up the wrong tree here. So a no-op should be incrementing program counter. Okay, well, at least I've got something that's testable. That all looks correct to me. So this most significant bit here should be the increment, and it is not. So this should be incrementing the program counter. All right, so 0, 1, 2, and I don't have a good view of this. 3, 4, 5, 6, 7. So is control ROM 2 not right? Because I should see that increment for the program counter. What is my address? All right, so that's correct. Now here's a dump of control ROM 2, and for address 0, the most significant bit is set. So for address 0, assuming that my new EEPROM is working properly as it should, I should be outputting. So let's see here. Chip enable should be here, that's low, and I believe that's write enable, that's low. No, not write enable, output enable. Write enable's high. So I need to dump the contents of this. And for some reason, the first byte of that EEPROM does not have the right value in it. That's interesting. I cannot explain why that would be. Let me rewrite it. Okay. And again, dump it. Well, that's correct now. Cannot explain why only one of them would have been off. Okay. Well, that actually incremented properly. That's working just as it should. Now, it kind of makes me wonder if I really needed that no-op in there. So I'm going to reset and just give that a test just for my own sanity. I'll be right back with that. Okay, what's interesting is I just got the exact same problem, this time on the least significant byte of my program ROM, where the first address had a null inserted and basically everything got shifted one address up from there. This is starting to feel like a situation where my Tommy prom is acting up, or Minicom, which is the tool I use to program to interact. I probably should be using PuTTY, but I got to figure out how to send things by X modem using PuTTY. So I'm gonna have to dig that up a little bit and give that a shot. Alternatively, I could try to rewrite the Arduino code onto the Tommy prom, but I really don't believe that's the problem. The most recent significant change to my tool set was my computer upgraded. So I'm gonna give PuTTY a try. I'm gonna do that off camera and see if I can actually get that programmed. Okay, I was able to get the proms programmed again. I wasn't able to use PuTTY. It doesn't support X modem, which is how you transfer the binaries. So I had to go through Minicom again, but it did work this time. So there's something going on there that I don't have a good answer to. Let's power it on. So that's working. It's pulling the correct bit there. That's working. That did not work. So that should have been an instruction suppress. And I've got an instruction suppress here. I've got a main bus assert, it's latching. But it didn't suppress that instruction. So that is now in this section, and that is something that I was battling with in order to make sure that we got that correct. Now, there is a timing issue in here, well, in here related to instruction suppress. It's the next day for me, and I sat down this morning in order to take a look at the circuit again and refresh my memory as to where I had left it. And I've noticed something, and I believe that this is a relatively simple fix here related to instruction suppress. So I reset the circuit. My instruction LED is on, meaning that the instruction is going to pass on up into the instruction register. This is a move instruction of the next word in the instruction stream into register R1. When I advance that up here, the contents of the ROM should be such that this instruction turns off. So I should never have both of these two on at the same time. The main address assert and the instruction assert, those two should not be active at the same time, but they are. So looking at this, I believe there's going to be one of three different problems here. The assert is handled here, by the way, in Control 3. Problem number one is that the firmware is not written properly, and therefore instruction suppress is not happening. That wasn't a problem before. I did check the code. It is not a problem today. Problem number two could be that I have the same problem I've had with other EPROMs where I've got an extra 0 inserted in front of this ROM, basically shoving everything to the right one address. I did check that as well, and that is not a problem. So the EPROM here is actually good. It's got the right bytes in it in the right positions. Problem number three, though, and I haven't checked this one, could be that I've got the wiring wrong. This is probably more likely in that I've got an incorrect address being presented to this EEPROM, and as a result of having an incorrect address presented here, I've got the wrong data being returned back. So that I can check relatively quickly using the logic probe. So power and ground on the logic probe. So this is an address line, and all of these are going to be address lines here. And I have a floating pin. That looks like address bit 0. That would certainly do it. Okay, everything else is deterministic except for address pin 0. On this one, address pin 0 is connected. Unfortunately, address pin 0 was the... Oh, wait a minute. That's not right. That's correct here. So I've got it on that pin, but I don't have it up here. Seriously. This thing has been the bane of my existence. And I am just going to cheat the snot out of it. Okay, let's try that again and see what that does. Oh, that didn't help. I still have soldering iron. Dumbass. Okay, that's still low. It should be high. Okay, that's floating now too. That's floating now too. Okay, these are all symptoms of the real problem. I'll get to that here in a second. But pay close attention to some of the problems, some of the symptoms I'm actually experiencing here. That's floating. It should be pulled low. So I've got to pull down here, which is not pulling down. That's an interesting failure. .3 volts. Thousand ohm resistor. Any bets? Well, that's right. Is that pulling down too strongly? Okay, that's a 10,000 ohm resistor I've put in its place. Okay, that's got the right address on it now. That's got the right address on it now. I was not prepared to overwrite this yet, but let's go ahead and do that. Probably shouldn't be doing that with the circuit active. That's still not working. That's enough to make you nuts. How's my output? I've got this all messed up here. That's where my problem is right here. What have I done? All right, so I need to check some continuity here. I have these off by 1, which means that one of these is probably doubled up here. And I need to be able to get in there. So how am I going to do this? Let's take, this is a bad IC. And I'm on continuity here. Okay, so that first pin is not connected. Okay, so that should be ground, that should be ground. Won't be connected, won't be connected, won't be connected. This should be connected to that pin right there, and it is not. So I need to change this. Okay, let's give that a shot again. There we go. That's what I've needed to see. So, multiple problems. I have had nothing but trouble with this, and I need to retire it permanently. I had the address lines wired up here incorrectly. I had the outputs wired up here incorrectly. What a nightmare. Okay, so that's one. Let's go through the full test here. I'll bring the code up on the screen. I'll bring it up so I can look at it as well. So here's my value that I'm loading into, well, that ain't right. Let's redo that. So there's the value I'm loading into R1, which worked. This is my move of R1 into R2, so this value should come down here, which did not happen. I'm not advancing this as quickly. Yeah, that's very indeterministic here. It's almost like this is not resolving fast enough. Yeah, I clearly have some fundamental problems still to solve. My address here isn't changing. I have no assert out onto address bus 1. Why do I not have an assert onto address bus 1? It should be the most significant bit up here. That's not right. So I ended up spending a good part of an hour working on this. And what I've discovered is the solderful EEPROM boards, if they get bumped or jostled in any way, the relay will trip and there is a risk of losing the programming on the SRAM that's on there. Additionally, they can tip out, and once that happens, I actually need to wait for all the capacitors to decharge. If I walk away, that's at least what I think is going on. If I walk away from the circuit for a little while and come back, it starts working again, and the EEPROM ends up working. So there's something that is going on there that I just have not been able to get my head around. And I'm not going to try to do that in this video. The video itself is far longer than I had intended it to be. So I am going to make a note of that and try to see if I can figure out exactly what's going on. So ultimately, I have some instability here in these EEPROM solderful breadboards, if you will. And the instability is physical. It is not necessarily electrical. And the reason I say that is I've got the pins set very narrow on these, and they quite literally rock back and forth. I may have to replace the pins with something a little bit more robust, like what I've got in the PCBs here, so that it physically sits down and holds on instead of these little turned pin, which are very thin. They go into the breadboard much easier, but they also come out of the breadboard much easier. Every time one of these rocks out, it appears like I corrupt the first byte of the EEPROM. So something I'm going to have to get my hands around. Okay, that said, it's working. And if I go back to single step mode and reset, I've got my assert onto address bus 1. Here is my move of an immediate value into R1. And here is the immediate value that I'm planning on moving into R1. So that effectively goes there properly. And then I'm forcing the no-op up. This is a move of R1 into R2. So now that it's up here, when I clock again, it's going to move that value down. And then this is a move of an immediate value into R2, and here's the value that I'm planning on moving. So this will become 1, the least significant bit. And then this now is a move of the value of R2 into R1 after I get rid of the forced no-op. So that move was successful. Finally, this is a jump instruction, and this is the jump target back to the start of the program. So it effectively does that, which reloads the first move instruction. Forced no-op, this is the value that's going to be moved into R1. And so that works, and I'm pleased with that. So I'm not a fan of the instability that I have on the EEPROMs, but at this point I'm going to have to continue to move forward with those. I will come up with something that's a little bit better, but my challenge is being able to fit them both into the breadboards as well as into the TinyProm programmer. So I'm going to make a note of that. I'll bookmark it. I'll come back around to it. But these are just temporary for the breadboard build. Once I get to the permanent PCBs, I do need to come up with something that's different. That leads me to another problem. The build is getting very large. So I'm either going to need to zoom out more and show more of my desk, which is going to make everything harder to see, or I'm going to have to slide things around a little bit and zoom in on the parts that are relevant to the particular topic. Not exactly sure what to do with that until I can get more of this converted to PCB, but I do recognize that things are going to get rather large here in the screen. In the next video, I'm going to make it even worse by pulling the ALU back out. And in the next video, I'm going to reintroduce the carry flag and actually all the flags, but conditional execution back into the build so that we can get that timing assessed and make sure that all of that is working the way that it needs to. After that, then we can actually move forward with adding two numbers together, something I've been looking forward to for quite some time. We'll see you soon.